Hey everyone, this is Aarav representing Physical AI with Aarav Bedi, and today I'm here with Vivek and Anandhu, who are the CEO and CTO of Zeus Robotics. So moving a little bit ahead, let's get some sort of introduction from Vivek and Anandhu, and then get started with the podcast.
Yeah, sure. Hi, nice meeting you, Aarav. So myself, Anandhu, I'm the CTO of Zeus Robotics. Along the way, I have built multiple robots from starting from college to from now on, and we have been admin, we have good experience in the robotics side of building different hardwares, and I've always loved working with robots, especially like small toys and machines from my childhood, I would say, and I've been a very adamant student of the electronic side of things. So yeah, so right now I'm continuing as an we are building robots to automate logistics in hospitals. Yeah.
Yeah. Hey, Aarav. Thanks for having me in this space. Myself, Vivek. I'm the co-founder and CEO of Zeus Robotics. We are building autonomous robots to automate the in-hospital logistics, like the movement of blood samples, linens, pharmaceuticals inside the hospitals, so that the nurses and healthcare staffs can spend more time on patient care. So that's our idea. And talking about me, I'm a serial entrepreneur. I have a couple of startups back in India even before Zeus Robotics, and I also had masters in robotics from Drexel. Actually, we three have. Three of us have been together for the past 8 years, building multiple robotic systems, worked for many startups, and then finally incepted Zeus.
That's great. That's great. It's good knowing that there are a lot of people who have pursued masters in robotics long before this actual trend came in. So a question that just comes in my mind is why specifically healthcare? Like what? Because there are a lot of industries right now in robotics itself, like niche, maybe ag tech and like humanoid robots and like a lot of other companies as well. What led you guys to pursuing healthcare specifically?
Sure, that's a nice question actually. So we have many friends who are nurses and healthcare workers working in many parts of the globe, especially in US, UK. So while we were doing our masters, so our whole idea is to build a system which we can bring mobile based platform, integrate couple of adaptive manipulators which uses vision guidance. So and we can use it in multiple industries. So that was our thesis, and we were working together for a very long time on this project. And while we were in a call with a couple of our friends who are nurses, and they were very exhausted. So then I asked, okay, why is this the job that you are doing, or then you have to quit, or like you need to find some other. So then they said it is not about the patient care. Most of the time they have been pulled away from patient care to move things. So that's really like frustrating for them. So that moment we initially thought it was a single person problem, then we could just created some customer discovery calls with other nurses, created Google Forms. So then we find out so it is a huge problem, a global crisis, and that's where we really stepped in.
Yeah.
Hmm.
To add up just a few things on that, like what exactly to add on that is that like we truly believe in purpose-driven robotics to be at point on that. So it's like we believe that like if you understand the task flow and the routines of a space where it's happening, and we really understand the path of workforce happening, and it is easier for us to automate and get a very good grip on how to implement and develop the system to the whole together. So when you're looking at all the industries, if you are hospitals, I would say you will get the right kind of spaces to develop your product to be optimized to be deployed in a highly routine based reliable platforms where people need reliability to at the end of the day. So hospital space is a very good example to get that. So that is also one of the reasons why we went to the hospitals, and today it is a very important very important thing to look at this direction, because like hospital workforce shortage is a very real and important thing which is happening right now, like the shortage of workers in the hospitals, and like so able to save at least a portion of their time to look after the real job. I mean, like the patient care they want to do is will give like multiple magnitude of bandwidth for them to work in that space. So I think
Hmm.
for all that came together for the hospital side to start with. So that's why we picked up hospitals to start the project.
Hmm. Yeah, that makes a lot of sense. A couple of things that was coming in my mind right now, related to healthcare is that because there are so many hospitals around the US and everywhere around the world, and there are a lot of like regulatory terms you have to keep into mind. Like maybe, we have seen a lot of news online which says like a patient was worked on virtually using a robot and stuff like that. There are other things like maybe a needle or like an injection is supposed to be passed from one side of the building to the other side, and everyone's busy and there are delays, so we are pushing a robot ahead. All of these come with a lot of like regulatory terms. Maybe like, you are probably not deploying the right injection to the person, or maybe the robot is making a sort of mistake. Maybe it's not working on the robot properly. And obviously, like all of these three things go through getting um, acceptances from like governmental organizations and a lot of things like that. So, are there some of these related healthcare factors which you took into consideration before building your MVP model, or
Yes.
are you doing it while building it?
No, but that's a very important question you asked right now. So this is a very important critical decision which we have to take before building the product, especially in this space, because it, as you said, there is a lot of regulations and licenses which you have to get before deploying the robot. But a huge chunk of it can be actually mitigated if you clearly design the end-to-end point where the robot is supposed to deliver. Like for example, if you can just eliminate or like isolate patients interaction with the robot, that clears up a lot of chunk of, I would say, like regulations for you. So if it is a robot which is actually servicing from one healthcare workers to a trained healthcare workers to another healthcare workers, that changes a lot of the game. The same happens for the robot hardware too. Like let's say if you are trying to rely on hospital infrastructure, like you need their internet connection, their Wi-Fi, their network to communicate to your server outside, then your deployment process will get like expanded like for so much huge time. So it will be hard for you to scale up very fast. So it is and also infrastructure dependent. Like let's say if you deploy the robot and you need to change something very paramount in the side of the hospital infrastructure for the robot to operate, that will also bite out too much time for your the scaling up process. So we build this product looking at all these sectors so that once you stabilize the product in the operational settings, like the nurses says that after running this 3 months pilot, which is going to come up next month for us, after that 3 months pilot, if the nurses give me a thumbs up, hey, this is a reliable, repeatable robot which I can use to take supplies around the hospitals. If we get that after the 3 months, then for us to scale this product to, let's say, next 100 robots, it will be, I would say, at least 10x easier than any other companies today in the
Yeah.
market. So we build the product looking in that direction, so that once we solve this problem of reliability, repeatability, and building that confidence from the nurse side, it's easier for us to scale. Yeah. So that's how
Yeah.
we took it.
So adding to that, I would say, look, we are only automating the non-clinical workflow.
Exactly.
We are never touching any clinical workflow or operation. So we don't need any HIPAA regulation. We don't need any FDA clearance, because we are never touching, as Anandhu said, we never touch hospital Wi-Fi or network connection. We never touch the infrastructure dependencies. All these because even before building Serra, it's our robot, we have been in discussion with the multiple healthcare administrators even before we building it. So that's how we designed our robot. So with all these, the regulatories for us is very, very much lower. We only need a UL certification to move proceed.
Yes.
Hmm. Yeah, yeah. That makes a decent amount of sense. Yeah, I think all of these regulations create a huge, like, chaotic situation,
Yeah.
and I think you
Exactly.
guys have gone right past it, and it's amazing. Um, You know, some of the things I was thinking of, like, the non-clinical things, there are a lot of things which are supposed to be done in like the healthcare, like just a hospital in general. Um, are you guys planning to make an MVP model for separate clinical tasks, or is it going to be one specific robot which runs like 5 to 7 tasks together?
It is
It's
up. Okay.
Oh,
Yeah.
sorry. Oh, yeah. So I will tell what he was going to say. So it's like it's depend upon so if you look at the hospital settings, it's mostly about departments. Like is it from the nursing department of the clinical side, or is it from the supply side where people are taking off the cleaning and all those stuff? So what we actually do is we actually talk with department heads. For example, like if you look at the pilot, looking at the pilot which you're going to do next month in that side, like we are actually talking with the head of the nurse department. Like she is the actual coordinator for us to to do all the things there. So it is about like what is the exact task the robot is supposed to do, and like so that changes everything. Like inside the robot, what kind of cabins is coming in, like what all, like we have a robot version where the base cabin is actually temperature controlled, which means that like if hospitals need to transport like medicines, which is actually can only be stored at, let's say, at 25 degrees Celsius, or like, like a room temperature kind of thing has to be maintained, we can do that. But so it is actually dependent upon like what exactly we deploy the robot in the hospitals for, because but hospital by hospital, like their traffic, like the volume of things they transport changes enormously, because some people will have like very strong this logistics on the supply side of the things to moving things. Some will have very strong on their moving medicines across the what kind of thing. So looking at the volume where we can help them maximize their our input, we just deploy robots here. So we have like 3 to 4 versions of the same robot to us. So what makes us do this is because our robot design is actually supposed to be like that, because it's a very modular design, which means that the
Hmm.
functional part of the robot, where the mobile based platform and the manipulator is actually a very common part for the all the 4 kinds of robots. Only thing which will change is the like the part of the robot where like we actually use it to carry things around the hospitals, like the cabins, or let's say in some hospitals we don't need to put the fingerprints like the biometrics, because all the nurses always use the gloves. So we just use the RFID and their the some markers for them to add the pin or something like that on the cabin to add that. So these are things which we can optimize very easily today in this today's world, and without adding much more capex or a cost on the manufacturing of the robot. So that's how we take that, and yeah, move forward. Yeah.
That's actually very interesting. These are some of the things in healthcare which are not being looked at right now, and you guys have literally
Yeah.
got in at the right time,
Yeah.
because there are a lot of people who are coming in and out of the country, just not the US, but all over the world, and
Yeah.
everyone has their own, things in the healthcare. So, yeah, I mean, at a company like yours where everything is basically being done from scratch, I've heard like you guys are still bootstrapped. What
Yes.
are some of the safety precautions you take before diving deep into this? What are some of the mistakes you made while building the MVP, and how did you guys like come out of that?
Yeah, good question actually. So initially, like, the first thing that we have done, as I said, it is the customer discovery. Like, we exactly ask healthcare administrators what exactly you require in a robot. Rather than building with our own conviction, we took input from several healthcare workers and healthcare administrators who face this real problem. Because if there is no pain or there is no problem, it is hard to sell a product. So initially, the first thing that we took to initiate is the customer discovery. With those input, like zero, some of them said, okay, it is hard to deploy robot, or it increases the deployment friction when robots use their IT interface or IT networks. And some of
Yeah.
them said size is really a matter. So that's why we should make our really compact, like 4 into 2. We have just 2 into 2 4 feet, and so these kind of input give us more conviction to the problem to build one design, Sarah. And as you said, we are just bootstrap. We only just we angel funding, a few amount of angel funding. We haven't done our institutional round. We are heading with our first institutional round. We have just opened our pre-seed round right now. So out of these, the we the one thing that we came up is we built a CU from scratch to an MVP and heading for a first pilot deployment in Tennessee with this bootstrapping. So it was it was always about initially we got those inputs. Without those input, it would be delayed.
Yeah, just one small thing to add here is that when you say inputs, like actually we had inputs from like I would say 3 different continents. I would say because like because like
Yeah.
we have very good well-wishers and like friends who are actually hospital workers in Europe, especially in Europe as well as in Middle East. Because we are from India. Like so.
Okay.
So we actually pass out like Google Forms, and actually we had interviews with them, and like because they will just come to the video calls and have chat with us and like say what exactly the problem is, because and like so we actually looked at them and see, hey, why this is not such a huge, it is technically it is not a very I would say it is a solvable problem like deploying robots, but nobody was able to be scale up in the sector because of these issues. So okay, so we actually talk to them and see how exactly they want to see, and so we will just talk to them. "Hey, this is we are going to build a robot. The robot will come like this, like it will pass through the corridors like this. It will end up operate the elevators like this." So they would say it won't be like it would. So they would give their feedbacks to us, and so from there we started building and then finalized to a product, and then that's how we finalized the thing. Yeah, yeah,
Yeah, yeah, yeah. Yeah, definitely. I think customer discovery is the most important task while building a startup. If you don't understand the pain points of any client, I don't think you can sell the product perfectly. Because if you manage to get into the market, even after that, selling it and actually get revenue out of
yeah,
it is a huge pain in itself. Um, just talking a little bit more about the startup space. I know that, customer discovery and everything is super important. And also, it is really important to know which market are you actually trying to get into. But there are a lot of startup founders in the industry of like robotics in general who are trying their best to get hold of clients and talk to as many people as possible, but there are still a lot of issues they go through. Let's say, for example, like any robotic company is trying to sell their product, but they are barely able to get clients. Is there something you guys have like a value proposition which you would give to these clients that would instantly make them say, yes, like we want this in our hospitals?
Exactly. So that's what I said. So initially, we talked with multiple hospital administrators who already tried to deploy robots on their hospitals. But the
Okay.
majority of issue they face is the first thing that founders or like the company or startup face is the deployment cycle in hospitals or in other industries. Even to get an LOI from a hospital, even a mid to medium to large hospital, it would around take 6 to 9 months to even to get an LOI or a decision. But in our case, as I said, the deployment friction is very, very less because the first thing that we have worked on the deployment friction. So when you have clarity on what is the problem and what you are making and how will you make it. So if you are very clear about these three questions, so it shows that your product is very, very, the best thing that the client can have. So when a competitor and us, like I'm just giving an example, okay, if a competitor and us send a pilot proposal to a hospital, it is likely to get a sudden yes from a hospital for us because we never touch their IT integration. They don't
Mhm.
want to spend a single penny on their infrastructure to deploy this robot, and they don't have to spend a bunch of money upfront like a huge capex. That is one of the major hurdle for hospitals. So these are the things that we like have a clarity, and we just even outpointed while designing our robot. So similarly in different spaces, as you said, different industries, startup founders need to focus on, okay, we need to build product for the client, not for us. Like what's their pain point? Okay, what's the deployment friction? You have to understand the deploy. If you understand a deployment cycle, and you can thoroughly reduce those frictions, that's it.
Yeah, yeah.
yeah. So
Yeah, it's really, yeah, yeah, you can
yeah.
go on.
Yeah, sorry. I was so I so I, from my side, I would say that there's like three things which will help you. This is a very I would say nobody can answer this perfectly because such a this question. So I would say like three things can be help you in this. One is that okay, you are going to deploy robot in hospital, which is not going to be easy. Is it a plug and play system? If yes, that will help you. That helps you a lot. Two, like, what is your track record? Have you run this product in and hospital settings for how much time? Like, and what did okay, we did this for this much time in these hospitals. That helps you a lot if you're going to another client. Then third thing is that like, okay, if you run like for let's say 3 months somewhere, and what is the gain that you brought to the hospitals? Like in the unit economics, like how much of hours they gain because of robot delivered these things to this place. If you can show these three things to hospitals, and you are actually you are a very one passionate team about building that help you a lot in this direction. So this is the three things which we focus and we talk to everybody in our team. This is our focus on going forward too. So yeah, so these are the things which I think three things that would help us to mitigate at least a little way in this direction to deploy more robots. Yeah.
Yeah, yeah. Very interesting. I had one more like related question to the startup side, and then maybe we could go a little bit more on like the in-depth MVP building and everything.
Yeah.
From all of these points which you put forward, something I realized is hardware in itself is a huge scope. Like it requires a huge amount of funding, huge amount of R&D, MVP modeling, errors, things to fix, and do pilot builds before actually getting massive in the market. And these are a lot of things that are supposed to be taken into consideration for hardware in itself. So a question I had for you guys is, how are you typically, testing out these pilot models? Is it like you have your own warehouse where you test out with a non-clinical task over here, or you have pilot clients?
No, we have a warehouse kind of setup, which is a multi-floor thing. We have a small elevator kind of setup, whereas what is actually expected in hospitals. We build the MVP, and right now, as we say, it's actually testing in that warehouse for the pilot coming up in next month. So we have
Okay.
it has long corridors, multiple rooms. So we will tag it, couple of floors, and as a keep it as an RS, a kind of a map which we have on the DB. Then we have same goes for the elevators too. So we deploy each system individually, state by state, and get the feedback for all kind of system before going to an actual pilot. Yeah. So
Mhm.
Like we replicate the same scenario
yeah.
like
And
hospital
also like
settings.
many people has helped us here because we are actually we don't have we have been a part of many accelerator programs and like many working with many people closely who are big shots in the places which we are, so they are very I would just want to say that like all those people have helped us immensely from getting like like talking to hospital people to get a pilot from there to getting a space to test the robot. It's not an easy thing, and like so they have helped us in every way. For that is the reason why we are able to. So yeah, I just want to mention that. So that's how we go to all those things, and yeah, we're doing that right now.
Mhm. Yeah, yeah. Yeah, that makes a lot of sense. I think it is important to do all of these testings before you actually build the trust of any client, and it is really important to understand that scope as well. Just thinking about all of these things and moving a little bit more to the technical side of a hardware startup, especially in healthcare. Obviously, like we have been learning a lot recently where it says that, making a hardware can be done, writing a code is super easy with Claude Code or like OpenAI or anything related to that. Um, but then the real issue right now is that how do you take this simulation into the real world? So sim to real is a massive issue in the robotics industry right now. I
Yes.
wanted to see like what are your thoughts on this process? Would you use simulations to predict into real world, or are you doing it like hard coding by yourself?
No, we use so we if I want to talk about the little bit of hardware backend for ourselves, like we basically run on mostly on NVIDIA platforms, and we use their softwares heavily to generate, like for example, Isaac Gym. We are using OpenGym, we are using Isaac Sim and RL Isaac Lab for as a full integrated system to develop things. So how I talk to with my teams and we get through this process is that like we actually reduce the goal for the task. Like for example, let's say what is doable, what is not doable in the system. So if we are going to train in simulation and it's going to transfer to real world, what is possible? So what if, for example, to tell an example, I would say that like the most I mean say the most like the most intense part where we use the simulation is to train the robotic arm to manipulate the elevator boards. So that is a
Mhm.
if you that is an end-to-end system which you can actually transfer to the real world, because it is starting from robot based link, ending at the elevator pressing buttons. And Isaac Sim is good at everything. Like it is very good at giving you good force feedback from the from the touch sensors and pads. You'll give you good camera feedback from the depth quality for the data you are getting. And also you can the fundamentals for the input from the like it's like the fundamentals for the training model from the real world and the simulation is as close as possible. So you gap the task between that. You actually slot the task between that, and you start training on that, and then you can apply whatever task whatever normal things industry follows, like domain randomization, like whatever random things we can add to add a future extraction based upon different things. Like so, we can add those things to give maximum results. So other than so it is even though it's such a huge infrastructure, finalizing to or use it where we want will give you
Yeah.
maximum benefits in the real world. So that's how we tackle that. Yeah.
Mhm. Mhm. Yeah, that's a very good point. Just talking about like sensors and stuff, I was just thinking about it right now. Like you said, pressure and all those things. Um, there's this new wave of like tactile sensors. There's like touch-friendly sensors which
Yes.
can understand and feel.
Yes.
I wanted to get your thoughts on that. Is tactile sensing going to be an important aspect in the healthcare robotics industry or not?
Absolutely. It will be one of the most important part in all robotics which you see right now, like where the it is actually manipulation is required with the help of like arms, robotic arms with the hand with the robotic hand kind of setup, right? So because if you look at what robots like your humanoid robots or like whatever robot industry lacks today is the feel or the is the feel of the feel on the robotic hand when it manipulates some substance or something or some objects it's in its camera view. So that is a very important step. So that declares how you should approach the target, target object, or like what is the target. So that is a very important thing. And like we have actually, for example, started process of integrating that to a system where like in the next version of our robot actually, which designs are going on, it has an manipulate it, the same design the manipulator, but end it will have an a robotic hand kind of setup, like which we see today in industries, right? Like the all
Yeah.
the many arms are like the palm arm with the fingers is coming out, right? So with that integrity, you will be able to actually pick and actually load the robot by itself. That actually create a lot of value. Let's say if a robot can comes to a place, identify what is supposed to pick up with help of the camera in its robotic manipulator, and if it is able to gently very precisely able to load itself and is able to deliver to some other place, that creates a lot of value. So that tactile sensor which you're talking about is a very indispensable part of the whole chain, I would say. Yes, it will come, you will see
Mhm.
more often in the system. Yes.
Yeah, yeah. And a question that came out of this explanation which you just gave is like, obviously, when you are training the robot, in-house robot training and all, you are collecting huge number of data sets and huge number of value points and like, different variables, including different sensor numbers, and you have to build like a sort of set range of like which one is a success run and which one is the failure run. What do you typically do, worst case scenario, that your robot actually while doing a test run it fails? Like, do you rerun the entire process, or do you understand the scope of problem and then categorize it with like a specific timestamp and then rerun from that step, or do you rerun the whole process?
Yeah, so this is one of the most important steps in development cycles. It is the robot debugging side. So what we do is that like so whenever we are doing a test, we actually create a very elaborate log files and debugging setups to even if before failure what exactly is happening. So we have this well-defined states, we call it. Like what state is robot actually is in? Is it in pre approach state to an elevator? So what are the things should do, checkpoints it should go? What it didn't came through? Or let's say if it was able to identify a certain feature from the environment, from where the feature came in, like is it from the lidar or it came from the depth camera? So like we will keep all those things while testing, and we see the how it is reacting to the which sensor is performing at which conditions and why it is failing. So this is the not so spoken side of the robotics, which will help you distinctly from in innovation, I would say, to reduce your development cycle time, I would say. So how much deeply you understand the sensor integration part with the software which you are using on the top layer makes a huge of difference in your deployment. Like
Mm.
how reliable your robot is going to be in an hospital where nobody is watching it around depends on these factors, and it is the most important thing in the development of a robot. And we have elaborate settings to record that, document that, and if something falls, we come back and ask, hey, this is not supposed to happen, how did this happen? This is the so that gives you much more grip on the we call it sensor integration layer. So it's a very important part. And like because there is actually, if you try to pick up a lidar, there are actually, I would say, more than 20 different types of lidars available in the market right now, same price range. But these 20
Yeah,
different lidars will have, or other sensors will have, with combination of other sensors will have completely different output with another software. And environment
yeah,
lightings, like how it is mounted, how the lidar mounted to the cabin is a very important part. So all this comes to this thing. So this is a learning process. This is a real experience you get on, as I said before, doing playing with the real hardware and trying to deploying it in the real world. Yeah, so that's how we tackle that.
Yeah, just add
Mhm.
to Anandhu because, as you said, we just need to be super confident in our product because, as we said earlier, we are deploying it in a hospital. After nuclear engineering, hospital have the highest number of regulations.
Yeah.
So even if our product doesn't have any kind of effect with the regulation, the whole workflow is under control with many laws and regulations. So so that, yeah, just that's
Yeah,
what I
so
said.
keeping a track
Keeping
of the whatever happens in the even if it doesn't fail, like keeping a track of the states where robot goes and the observations it had there, builds a lot of reliability for somebody technical in the side of this thing to convey them to, hey, look at this, this is how happened. Okay, they will say give thumbs up on that looking at that side. Yeah, so it's a very important
Yeah,
case here.
yeah. Yeah, no, that's definitely the right steps towards something like that. But quick, just a small portion of that was I was also thinking that in while you're doing your own testings and stuff, obviously sensor integration is one of the most important things. And but apart from that, also there are a lot of things related to how your robot is failing in your pilot build. And so that this does not happen in the real world when it is actually deployed into the hospital, there are a lot of like things which are supposed to be taken into consideration. Some people just like, simulate it and make a synthetic data set.
Hmm.
Some people just redeploy the robot to collect data again. What are some of the things you feel are the best way to replace as many failures with more number of successes before actually deploying it into the hospital?
Yeah, so it is about, as I said again, it's about choosing like what task you give to the simulation side to give you the result. Like for example, right,
Hmm.
say there are things which should not never fail, and there are things which if it fail you can do and bypass and take other path to that. So there that is
Yeah.
because I know like if you look at the past, let's say 5 year in robotics, the most important development happen is not the any physics engine or like any good simulation side or things like that. What happened is that like our ability to integrate huge amount of data into a small pipeline and get result from that. Like for example, the biggest example is the Isaac the simulation Isaac sim or the Isaac lab Aarav. Like how much amount of training data you can put in and get result from that is like it has actually say changed like paramount, I would say, like in that scale. But
Yeah.
still we are not able to do or train all tasks in the same setup. Why? Because there are certain tasks which is even more complex than that. Maybe it is because of the sensors which we use. Maybe it is because of the perception pipeline which you have set up, or because of the planning which is going after that. We don't know. Like I would say, like so. This is so. It is about deciding like how like which are you betting on. I am betting my navigation is not going to fail. What no matter what, or let's say
Hmm.
my manipulation with my elevator on the robotic with this setup is not going to fail no matter what. So if you
Hmm.
building small confidence along the path on different this is why I said state is very important. Like I'm saying at this state my robot is not going to fail. If it fail you are I mean as a technical side person, you should be able to vouch to that. That's how you
Yeah.
come from a MVP to a pilot to a product.
Hmm.
So this is the small unit things which you can actually brick by brick build across the way so that you can actually say, hey, this is not going to fail at these settings. So that gives you much more bandwidth and room to see, okay, this is going to fail. If it fail, what I should do.
Yeah.
So yeah, so that and also to build a final product, I would say it will take more than a pilot. Even after running a pilot, maybe some other hospital in some other place could have some problem which should come up. But that should not be a common thing happening across the whole fleet, right? So those things which we can mitigate and take up beating and slowly try to bring up. But as a general thing, we should be able to confidently say to somebody when we deploy that, hey, this if somebody says your robot failed at this corridor, it is not supposed to happen. It will not happen. You should be able to. You should have the data and the credibility and the confidence in your hardware and implementation to say that. If you this is very important. If you bring this is a very time consuming and painstaking process. But if you build your team and your technical side across this will pay off in a huge way, in a very huge way,
Yeah.
because this same thing can go not only in hospitals in different sites. The only thing lacks is your understanding of the whole sensor setup and the capability of the robot. So always think like that. Even if you say hospitals, it is not hospitals in US. You are talking about hospitals all across the globe, because everything is so that is a very important part you should actually document and account for from in a very technical aspect. So that's what we do. We thoroughly follow that.
Mhm.
Yeah,
No, that's a very detailed explanation.
yeah.
Thank you so much for that.
Yeah.
Just moving towards the end of the podcast, there are just a couple of questions. This entire podcast was simply to make the newer generation who are trying to get into the robotics industry understand what all steps are supposed to be important while building or working in the robotics industry. So, a question I have for you guys is, if you were to start right now, when the robotics race has been going on for the last like 10 years now, almost a decade, what are some of the things you would keep in mind before deploying? So I would say, um, one on the software side, if you're trying to get into like the automation space in robotics, and then one on the hardware side, if you were to get started with hardware from scratch, what are some of like the bigger, websites or books or articles people should read that can help them get into this field easily?
So yeah, from a CEO perspective, I would say start networking way before you start a company. So that's
Yeah.
one
Yeah.
thing that I would really recommend, because as Anandhu said, we have been a part of many great programs.
Yes.
Like we are a part of the company lab accelerator program in Chattanooga, Tennessee, which help us a lot to get a pilot with the Erlanger health system that we are going to be deploying next month. And we have been really good connection with the industry leaders who are currently working on this project.
Mass robotics.
And we have been selected for a mass robotics healthcare catalyst program where we work with Mitsubishi
Mhm.
Electric and Yakuza.
Oh yeah,
So
that's
as you know, they are the automation industry leaders. So all these things comes from by networking. So even if you start networking at your early career, while if you build a product, you will get an immense help from people those who already have in their mid career on the same industry. So while you start a company, so as a CEO, like a perspective, I would say networking is the first thing.
yeah.
On technical side, I think he can.
Yeah, that's right. Yes. As he said, we cannot thank more than the people who helped us along the way to get to here. That's like phenomenal. I would say. Just want to add on that. So from the technical side, I would say, like reading papers and like technical theoretical things. Everybody can. It's freely available to everybody in the internet. You can just pick up on whatever you want and you can read it. But one of the most important things which will make you difference is that if you have a very at least a small robot, I would say, let's say like a 50 centimeter or a half a meter or 40 centimeters kind of a very small box robot which will actually very a small lidar or a depth cam to understand some QR codes are able to dock something kind of thing. A very small robot setup which you can actually test your learnings onto that will make a huge difference to that. And so that is something which I thought I took for granted, which is, if you buy something, if you're going to put it, it's going to work, but it's never going to happen. Even I want to say
Yeah.
that even the same robot won't work the same in another building as you work in the same building. So that's how we don't know what's happening, but that's how real world is. So the more exposure you and your robot get in the real world has no value. It creates the most of the value. Then on the software side, I think with this LLMs, like everybody is on the same page on coding side. Everybody, like there is no difference on that. It's about the ideas which you have. But one thing which add a lot of value is that you should pick up two languages. Like for myself, it is like Python and C++, which I think, okay, I am ready to go lock horns with somebody, that kind of thing. You should at least in two languages, which help you a lot. Even if codes come to you in prepaid packages, and as a, you can use it, still able to understand whatever is happening in such low levels, give you much more grip on your system and will much more reduce your debug time. So don't one thing I would say is that don't skip that part, like that hard part of understanding the language, implementing many things on the, even though they can code for us, it's very good to still understand all the all the bells and whistles and here and there, and so that understand, so that gives you much more confidence on the software side. I think you won't be an outsider, even
Yeah.
though, yeah. So once you go through that process, it's easier for you because there is somebody at your ability to write code for you. You can just go to the skim to the code, hey, and you can write notes and also you for debugging side. So as I said, robot debugging is the most critical part. You won't understand that because you won't know. You will think it's a perception problem or a planning problem or an control problem, but sometimes it will be an mislink transform between two coordinate frames. So understanding, trying about to pick that up will make a huge, will decide how good of a developer you are on the robotic side. So I think, and
Yeah.
all this stems from the thing that you have a real world robot with you. So other than that, like whatever your interest is in, try to read the new papers which is coming in from all the conference. So just right now, the computer vision conference for 26 released, and they released much of good papers. Just follow that. there is a very good community around to support you in ROS. Like they are actually publishing like things every year. There is a ROS discourse going on. Join that. There is nothing more than then have happy and be passionate about building robots. I would say, yeah,
And
yeah,
yeah, adding to Anandhu, there was and final thing I would say is if you have an idea, just start building a
yeah.
prototype.
Just building.
Don't wait to polish your ducks. Don't wait
Yeah,
to
overthink.
to overthink. Don't wait to project your financial projections.
Yeah,
Just build a hardware.
nothing is going to
Nothing is going to happen.
happen
Don't
your way.
wait to do have like institutional funding round
Yeah,
to like to make it happen. You can just
check
bootstrap.
it.
You just can make whatever in your hand. As Anandhu said, just build a hardware and test it out how it goes in real world.
Yeah,
It
yeah.
it creates an immense value rather than we have a polished
As a learner,
yeah, as a learner.
yes.
Yeah, no, that's an incredible answer, and I totally agree with that. I myself recently started getting into the robotics industry, got myself a 3D printer,
No.
made up my mind that now I'm gonna
Yes.
start
Yeah,
manufacturing and make my own parts.
yeah.
I had like LLMs open on my side. I was like, look, my servo motor is not working. This is the issue.
Yeah,
This is my FSR tactile sensor. This is not connecting. Help me with the wiring. There's a lot of friction. My math is going wrong. The fingers are not moving. And I think that gave a lot more knowledge, just as like someone who's trying to get into the industry. And in terms of like, the papers and events and everything you guys mentioned, I think ICRA and like
exactly.
Neuro IPS and like all of these big conferences which are happening all over the world actually give a lot more information. Whether you can attend it virtually or just in person or even just read about the research papers which are being published, I think it's a massive increase in the knowledge you are going to be gaining out of it. So yeah, definitely that was a great reply for
Yeah,
sure. And uh, so with this, like we would call it the end of this podcast and just, a couple of final words if you guys would like to give to the future generation of robotic engineers, then yeah, you can go ahead with that.
yeah. I would say we are not in a state to give that. I would say like we are just still learners. I would say passionately try to follow what you believe in. Don't try to overthink too much. Nothing is going to happen your way. Just start building from day one. You will be a learner at you will be a learner at the day one. You will be a learner at when you are trying to
Deploy 100 robots.
yeah, or park your boots. So same way. So always be in that state of mind. Things will. It's a as of now I have been in this industry for at least 5 years as a robotics engineer, like just as a robotics engineer. Before that I used to focus much more on electronics and building stuff, so like that's different industry, but I've passed in robotics I have for the last 5 years. I would say it's a very I would say very enjoyable, very passionate journey. If you love what you build, there is nothing better than being a robotics engineer and build the future. I would say that's it.
I don't know much about technical side,
Yeah.
but I have been built a couple of startups back in India as well. So the one thing I would really say to youngsters who are really want to do something out of their career, that is never give up. Like you have to, whatever the things happen, you have to stand up and you have to do your job. Even if you didn't get the result right now, it will follow on. Don't just work on result. Okay, just do the work that you have, and the result will follow on.
Yeah.
So never give up. That's our strategy.
Yeah.
Yeah.
Yes.
No, that's perfect. Thank you so much, Vivek and Anandu. It was great meeting and talking to you guys. And I
Yeah.
hope this
Thank you.
Yeah,
Thank you,
conversation
Aarav. Nice
continues
chatting with
sometime
you.
in the
have a
future.
great
Yeah.
session.
Had a
Yeah.
refreshment kind of feeling.
Yeah.
Thank you.
Thank
Thank you.
you so much. Thank you.
Bye.